Students, welcome once again in physics class. Today we are going to discuss numerical problems part I. So this is the first numerical. Calculate the moment of force of 16 Newton about an axis of rotation at a normal distance of 0.5 meter from the force. So distance given and force given, we have to calculate the moment of force. So as we know that moment of force tau equal to force multiplied perpendicular distance. So force given is 16 Newton, distance 0.5 meter. So put these values. 16 multiplied 0.5, remove this decimal, 5 by 10, 16 5 by 80, 0 cut with 0, then we have only 8 Newton per Newton meter. So 8 Newton meter is the moment of force. Now the second is, a nut is opened by a wrench having 20 centimeter arm length. If the least force required to open the nut is 3.0 Newton, calculate the moment of the force. Once again we have to calculate moment of force, but here the distance given in centimeter. First we will convert it into meter. So distance, that is length of wrench, given at 20 centimeter, and as we know that 1 centimeter equal to 1 over 100 meter. So centimeter in place 1 over 100 divided with 100, 0. So 20 over 100 meter, and force equal to 3.0 Newton. Put these values here. Force multiply distance, 3 multiply 20 over 100, 0 cut with 0, 3 2 are 6, 6 by 10. So 6 by 10 and equal to 0.6 Newton meter. So this is the moment of force. The third one, a child of weight 20 kg kilogram force is sitting at a distance of 1.5 meter from the fulcrum of a seesaw. What is the moment of the force of weight of child? हमें given है 1 kgf, that is 1 kilogram force equal to 10 Newton. First we will convert the 20 kgf into Newton. So weight, that is force, equal to 20 kgf. So 1 kgf means 10 Newton. So 20 multiplied 10, that is 200 Newton. Distance 1.5 meter. So once again, formula of moment of force, F multiply D, force multiply distance, 200 multiply 1.5. Remove this decimal, 15 by 10, 0 cancel with 0. So 20 multiply 15, that is 300 Newton meter. So this is the moment of force. Numerical number 4, an object is pivoted at a given point. A force of 6 Newton is applied at a normal distance of 30 centimeter from the pivoted point. What is the moment of the force? So force given is 6 Newton, distance given is 30 centimeter. Then once again centimeter will be converted into meter. So force 6 Newton, distance 30 centimeter, divided it with 100, it will be converted into meter. So 0 cancel with 0, 3 by 10 meter. Once again tau, that is moment of force, equal to force multiplied distance. Put those values, 6 multiply 3 by 10, 6 3 are 18, 18 by 10 equal to 1.8 Newton meter. So fifth numerical, calculate the pressure exerted by a force of 400 Newton acting on the area of 80 centimeter square. Now we have to calculate the value of the pressure. Force given है, area given है. So force 400 Newton, area 80 centimeter square. पहले हम इसको SI यूनिट में कन्वर्ट करेंगे. As we know that 1 centimeter equal to 1 over 100 meter, squaring on both sides. Now you will get 1 over 100 multiply 100, that is 10,000 meter square. So instead of centimeter square, you will divide it with 10,000 meter square. Now it is converted into SI unit. And as we know that pressure equal to force over area. So put these values, force 400 divided by 80 over 10,000 and equal to, so it will be multiply with the numerator. So 400 multiply 10,000 over 80, 0 cancel with the 0, 8 1 are 8, 8 5 are 40, साथ में 0 आ जाएगी. So 50 multiply 1000, you can write 50,000 Newton per meter square, or 1 2 3 4, there are 4 zeros, so 5 into 10 raised to power 4 Newton per meter square. Or instead of Newton per meter square, you can also write unit of pressure, that is Pascal. So sixth numerical, what force is required to exert a pressure of 2 multiplied 10 raised by 4 Pascal on the area of 200 centimeter square? So again we have to calculate the force. Pressure given है और एरिया गिवन है. So pressure equal to 2 multiplied 10 raised to power 4 Pascal, area 200 centimeter square. Once again we will be converted into SI unit, that is meter square, divided it with 10,000. So zeros cancel with the zeros, look at that, 2 zeros here, 2 zeros cancelled, and we have 2 over 100 meter square. And as we know that pressure equal to force upon area, so force equal to pressure multiply area. So put the value of pressure, 2 into 10 raised to power 4 multiply area 2 divided by 100. So 2 or 4 multiply 10 raised to power 4. You can also write it as 10,000. So zeros cancel with the zeros. We have 4 into 100, that is 400 Newton. So Newton is the unit of force. Now next is numerical number 7. A force of 2500 Newton produces a pressure of 50,000 Pascal. Calculate the area of the surface on which the force acts. So force given है, pressure given है, we have to calculate the surface area. So force equal to 2500 Newton, pressure given है 50,000 Pascal, and we have to calculate the area. So as we know that pressure equal to force upon area, cross multiply, area equal to force by pressure. So put these values. So 2500 divided by 50,000, zeros cancel with the zeros, 25 1 are 25, 25 2 और 50 होते हैं, साथ में 0 आ जाएगी, so it will be the 500. So 1 over 20 divided 1 with 20, then you will get 0.05 meter square. So this is the area. So numerical number 8, I have a stone of weight 80,000 Newton is placed on a platform of dimensions 5 meter multiply 4 meter. Calculate the pressure on the platform. So students, force given 80,000 Newton, area 5 meter multiply 4 meter, multiply both the terms, you will get 20 meter square. And as we know that pressure equal to force upon area, so 80,000 divided by 20, 0 cut with the 0, 2 1 are 2 and 2 4 are 8, 0 0 0, ये 3 0 साथ में आएंगी. So it will be equal to 4,000 Newton per meter square और pressure equal to 4,000 Pascal. Ninth numerical, the pressure exerted on a surface of area 0.5 meter square due to an object placed on it is 6 into 10 raised to power 3 Pascal. So pressure given है, area given है, calculate the thrust acting on the surface. तो हमें force, normal force calculate करनी है. So pressure given है, area given है, pressure equal to thrust by area, that is normal force over area. So thrust equal to pressure multiply area. So put these two values, 6 into 10 raised to power 3 pressure multiply 0.5. 6 multiply 5, remove this decimal, then it will be the 10 divided by 10 multiply 10 raised to power 3. 6 5 the 30, 30 by 10, 0 cut with the 0. So multiply 10 raised to power 3. Thrust equal to 3 multiply 10 raised to power 3 Newton, or you can also write it as 3000 Newton. So this is the answer. Numerical number 10, a girl weighing 32 kilograms stands on 1 foot. If base area of her foot is 80 centimeter square, then calculate the pressure exerted by her on the floor, given that 1 kilogram force equal to 10 Newton. So total normal force given है 32 kilogram force and 1 kilogram force equal to 10 Newton. So 32 multiply 10 equal to 320 Newton. Area given है 80 centimeter square. Once again it will be converted into meter square, divided with 10,000, 0 cut with 0. Then we have 8 by 1000 meter square. And as we know that pressure equal to force upon area, value of force 320 Newton and area 8 by 1000 meter square. So look at that, 320 multiply 1000 divided by 8, 8 1 are 8, 8 40 are 320. So multiply both the terms, 40 multiply 1000, 40,000 Newton per meter square, or you can write it as 4 multiply 10 raised to power 4 Pascal. So this is the value of the pressure.